Hello, I'd like to welcome you to EET-250, Control System Theory, for the spring of 2021. My name is Gary Millett. I'll be your instructor for this course. There's a lab component to the course, EET-250L. Professor Jagodowski will be doing the lab sections, I believe. In this course, what we're going to do is take a look at how control systems operate. Control systems are one of those topics that have been around for a long time, but very recently has gotten a kind of revitalization as we talk about Industry 4.0 and cyber physical systems, the Internet of Things, and so forth. It turns out that today we can take and build control systems into just about any system that would benefit from, being overlooked by, say, a microcontroller. So we start the course by looking and introducing classic control systems. These control systems have been around again for years and years. And then we'll finish that topic by looking at new versions. Some people talked about control system technology 4.0. And again, you may have heard the term Industry 4.0 to indicate what's happening presently today in this arena. Our next topic would be to take a look at embedded control. How does this stuff work? What's happened, where we come from, where are we going to with embedded control? And we finish that topic off by looking at typical embedded control hardware. And in your lab, I believe Professor Jagodowski will have you deal with things like the Board of Education or basic Stamp 2 technology, where you'll take and actually do some practical hands-on stuff with embedded controllers. I'm going to go into some of the newer stuff, do an intro to the Internet of Things, or IoT as we call it, get you into what that is all about. And essentially what it is having some type of control system that I can access over the internet. With the pervasive nature of the internet now, and with wireless internet technologies, it turns out that we can take and control things that are going on, in distant areas. We can also take and control geographically large systems, things like a smart grid and so forth, where electricity is delivered to a large area. The internet makes it possible, and wireless internet access also makes it possible to control systems like that, things that are geographically large, actually. After we do that, we'll also talk about cyber physical systems. And cyber physical systems are applications of the Internet of Things. You're bombarded with automobile commercials about autonomous cars and so forth. Well, there's many more cyber physical systems that can exist, and they are control systems that have very low latency. And we'll talk about what that means. After we go through all those introductory ideas and concepts, then we get into the hardware that makes all these things work. And our first topic is the operation amplifier. And the op-amp is an integrated circuit. It's been around for a long time, and it allows us to interface sensor systems to our embedded controllers. So we'll take a look at how op-amps operate. We'll take a look at the various op-amp applications that you can have. Most control systems have something called a comparator. We'll take a look how the op-amp can be used as a comparator. And I'm sure in your lab, you will do experiments with op-amps. After we get through basic op-amps, we'll take a look at some of the special purpose op-amps and some miscellaneous interfacing systems for sensors. After we're all done with that, then we'll take a look at mechanical systems that are actually involved in these control systems. We'll have a couple of weeks that will deal with sensors and sensor systems. We'll take a look at all different types of sensors. I'll also have a little bit of wireless networking. You can't do most of this stuff without wireless networking today. And we'll take a look at things like the IEEE technologies, like Wi-Fi and Bluetooth, and certainly cellular. We'll go back in the hardware looking at stepper motors, then control system actuators, take a look at switches, relays, and power semiconductors, and make these things work. Then the very end of the course, we'll revisit feedback control systems and look at the PID systems. As far as the course goes, the online version of this, there are weekly homeworks. The class is set up in modules, a module being equal to about 1 week's time. And it turns out that after each module, there's usually a homework. You go online, your Blackboard access will show that you're enrolled in this class, and you go in and you start with module 1, and you take and go through the module. And again, there'll be an assignment at the end of it, and it's due usually the week afterwards. And I think there's about 12 homeworks and maybe 2 quizzes for the course. If you have any questions, you want to email me. My email, is on the syllabus and on the Blackboard website. I'm located in Building 17, where I do labs during the week. You guys are down in Building 20, and it's conceivable I might drop down there someday just to introduce myself, so I'm a real person. But nevertheless, usually we won't see too much of each other. So again, you want to get busy with the course, and hopefully we're going to have fun taking a look at what's going on and how things are changing quite rapidly in this field. So let's get to it.